Okay, hello guys. Welcome back to Maths on African Motives. We are still on our mathematics grade 10, still focusing on our algebraic fractions. And it's very, very important that you understand your algebraic fractions to the extent of knowing how to add or subtract them, to the extent of multiplying and dividing your algebraic fractions, to the extent of even solving equations which involve algebraic fraction. So in this class, we're not going to waste much time. This is a direct addition and subtraction that we are going to consider. Let us take a closer look to say, let's say we are given two fractions to be added or to be subtracted. Okay, we've got two fractions that you're going to consider, that you're going to add or to subtract, or there are three, or there are four, or there are five, no matter how many fractions are there. Like what we have on the first question, we are given to add 2x over 3 plus 1 over 6. The question can ask you to simplify, then you are supposed to know that I'm supposed to add. Or the question can give you direct add the following algebraic fraction, or simplify, express your answer as a single fraction. Simplify as a single fraction in its lowest or simplest form, depending with the question, or just simplify. You are supposed to know what to do. Okay, so whenever you are dealing with addition and subtraction, what you are going to find is the LCD. You are going to check for what you refer as the LCD, which is the lowest common denominator of the given numbers. Okay? With this, we've got two ways that we can consider our addition with this LCD that we're going to consider here. All right, what is the LCD of the two numbers 3 and 6? The lowest common denominator. The highest common factor is opposed by what? The LCD. Remember, a highest common factor, you look for the two numbers, the one that is common, but the LCD, you have to take the one that we can divide. If we divide by these two numbers here, we obtain an exact value without a remainder, and that number must be the smallest, which is from the lowest. We must have the smallest value between. There are so many numbers that we can use that can be the lowest, that can be the common denominator, not lowest. That can be the common denominator. We can use 6, we can use 12, we can use 18, we can use, as long these numbers are multiples of these numbers, as long they are what? Multiples of the 2 digits that you're given. But of all these numbers, we need the lowest or the smallest. So the smallest one is what? Is 6. So meaning to say, on all these numbers that we could have considered as our common denominators for the both numbers, because we are referring to two numbers, 3 and 6, there must be a common denominator between these numbers, which is a multiple of these numbers. So the LCD is simply the multiple in this case. All right, is simply a multiple of what? Of the given denominators. All right, of the given denominators. So if we are saying it's a multiple, consider your HCF and your LCM, how you calculated those, that at least you can go back and revise from your mathematics grade 9, the difference that we have. But I hope that for now, you understand what I'm trying to say. If I'm saying a multiple, so we need the lowest common denominator from these two numbers, which we said is a 6. So with the first addition, you are going to use that common denominator on all these numbers, everything over 6 like this. Okay. Like I said, I've got two ways that I'm going to explain this. So what you do with this one, if you write the LCD like this, you are going to use it and divide back to the denominator of the first fraction. Okay, so you divide back 6 divided by 3, we get what? We get a 2. We divide 6 and 3, we get a 2. That 2 that you get, you multiply it to the numerator. So it is going to be 2 times 2x, this one. So you divide 6 divided by what? By 3. You get what? A 2. The 2 that you get, multiply to the numerator, okay? Plus the same thing, 6 divided by a 6 here. So it's the LCD, 2 to the denominator. So it's 6 divided by 6, which is a 1. The 1 that we get, it multiplies the numerator. What is our numerator? Our numerator is a 1. So meaning to say at the end, we are going to have 2 times 2x, which is 4x. 1 times 1, which is a 1. So this will be plus 1. Everything is affected by what? By 6. Everything is over that common denominator, which is the LCD. Everything is affected. Okay, I want to take you this way with this method here. Remember that if I am having a fraction 1 over a 6 plus 5 over a 6, okay? Or maybe whatever number that you can think of, what we know is that if the denominators, these ones, are the same, okay? I'm simply going to add the numerators together, these ones. Which concept is that? Remember that A plus B, everything over C. Where was this one taken from? It was taken from A over C plus B over C. Remember, we can separate A over C, B over C. So it means if these denominators are the same, if these two numbers, if these numbers here are the same, whether they're 3, whether they're 4, as long they're the same, it means we can even oppose it back like this, where we can add the numerators together, everything over what? That common denominator that we're given. We are taking it from where we used to separate. Now we are taking it where we are supposed to combine it to a single fraction. Remember, we are supposed to combine to have a single fraction. So if it is that way, it means here I can simply add 1 and 5 together, everything over 6, because we can see that we have got a common value already, which is 6. So there's no need for me to find LCD. I just take that, everything now over 6. So if I add this, what am I going to get? 1 plus a 5, this is a 6 over a 6. And we know that 6 over a 6 gives us a 1. So what am I trying to say? I'm trying to say if we can make these numbers to be the same, this C and C, if we can make these to be the same, therefore we can add everything over that same digit. Okay, now let's consider that. How can we make this to be the same from our question? I'm just going to work with the same question. Remember, we were given to simplify 2x over 3 plus 1 over 6. So with this method, what you just ask yourself is that with these numbers 3 and 2, 3 and 6, what can I do to make the denominators to be the same? Okay, if I know that the LCD of the denominators is a 6, which is common, and this 6 is a product of 2 and 3. If you multiply 2 and 3, you get what? You get a 6. So what you simply ask yourself is that what we want is to maintain our LCD, which is 6. Already here there's a 6, so there's nothing that I'm going to do here. There's nothing, okay? I have to focus with this side where I have a 3, but this 3, I must change it to be a 6. How can I change this 3 to be what? A 6. Like I said, 6 is same as 2 times 3. So that means if I multiply this here by a 2, it gives us what? A 6. But if we do this, we have changed our question. So we do not want to change our question. We want to have the same question that this one. So we are not just going to multiply by 2 here. We are going to multiply by 2 over 2. This is what you're going to do. what? So that, okay, let me get you back. I want you to get back to this. 2 over 2 represents what? It represents a 1. 3 over 3, also a 1. 4 over 4, a 1. So whenever I write a number over that same number, it means I'm having a 1. So if I have a 1 and I'm multiplying here by a 1, what does it mean? 1 times this, it remains as 2x plus 3. So it means I have not changed my question. But if I multiply by only 2 here, I have changed the question because it will be 2x over 6, which is it has changed. We are not supposed to change this 2x plus 3. We are just supposed to write it in another way. So we multiply by that number that is going to change this to a 6. But also to the numerator, we must do the same. Okay, let's multiply and see. You are going to see this one is straightforward if you understand it. Remember, our concept here for multiplying is that we want to have what? The same number 6, which you said our LCD is 6. So this 6 cannot change because it's already a 6. So you focus on the other number to be a 6, okay? So let's multiply the numerators now. So this is going to be equal to 2 times 2. So you don't divide because I said 2 over 2 is 1. If you cancel, you remain back with this one. Remember, to multiply by 2 over 2, we want it to be as a 6 in the what? In the denominator. So we're going to multiply 2 times 2 on the numerator, which is 4x, 2 times 3, which is a 6, plus 1 over a 6. Now that we have got the same denominator throughout, it means we can now add our numerators together. Everything over that what? Everything over that denominator, which is 6. So it's going to be 4 plus 1. Everything over what? Over 6. We are now taking it from our concept that if I have A over C plus B over C, it was taken from A plus B, everything over C, because these are the same. So I'm just going to write everything over that. So that is the advantage of having the common, to have the same denominator, because you can add or subtract whatever that you have. So as you can see, you're obtaining the same answer, just like this part. But there we had to find the LCM, our LCD. We divide everything by the LCD. We have to divide back this and multiply to the numerator. We divide also this, we multiply to the numerator. That is the difference between these two methods. So it's up to you which method are you gonna use. But I think if we work with the second one, it's going to be very, very good in our revision. So I'm just going to maintain that 1 or 2 questions, then we'll see. All right, so on this part, we are given number 2. Again, it is to simplify. So there we are given. So I just want to see this method that I just talked about here so that you can see how we can make this to be the same denominators throughout. Let us see this one. So this is what you're given, plus 1 over 3x cubed. Okay. So when you are given such type of a question like this, whether you are adding, you are subtracting, whatever that you're going to have, it's fine. It's not a problem to have it that way. You can maintain whatever sign that you have. As long as you have a minus and a plus, does not affect anything. Okay, but remember I said we've got 2 methods, and I'm just going to work with the second method that I said. We want to make these denominators to be the same. So to make the denominators to be the same, we must consider having the LCD of the denominators so that we can see what is missing on each denominator to be the same as the other denominator. Okay, what is the LCD of 6x, 9xy, and 3x cubed? Okay, considering the numbers 6, 9, and 3, we are going to see that the LCD there is what? It's 18. Okay, let's consider 6. Remember, 6 is a product of 2 times what? 2 times 3, 6. 2 into 3 into 6, that's 3. 3 into 3, that's a 1. 9 is a product of 2 numbers, which is 3 and 3. 3 is a product of which numbers? 3 is just a 3. So remember how you find your LCD or your LCM the same way. So your LCM, you have to consider where do we have a lot of 3, because this 3 is same as what? As 3 squared. So the LCM of the numbers is going to be 3 squared times, we also have a 2 here. It's going to take a 2. So 3 squared, which is 9 times 2, which is 18. Remember, how do you find your LCM from your grade 9? Okay, where you consider where you have got all the numbers should be part of your answer, and you have to take where the numbers are repeating, you take the one that has got what? The highest exponent. But to find the LCD, which is our lowest common, you can even, just by looking into your question, you can see which one is the number there. We talked about this in our grade 9, so there's no need for you to stress yourself, okay? So this 18 that we are talking about here is our LCD in terms of what? The LCM is the same thing. But I was talking about I was referring just the numbers in this case. Remember, we have got letters also, we've got variables also. We have got x, we have got x, we have got x to the exponent of 3. Remember, on the LCM, we consider the one that has got the highest exponent. So our LCD, we are going to take x to the exponent of 3. Okay, remember how you find your LCM. You take the one that has got the highest exponent. If you're talking about the HCF, you take the one that is common and having the smallest exponent. So that way that you find your LCM is your LCD, okay? Then we also have a Y here. As long a variable, a number, whatsoever is given here is given, as long it is there, as long you can see it, it must be part of your answer, which is different from the highest common factor, where you have to consider terms that are common, only common terms. But the LCD is the same as the LCM. So a multiple, it consists of all the terms that are present here that you can see. So now you are going to ask yourself to say, how can we make this to be like this? Your LCD. That is what you're simply asking yourself. How can we make 6x to be like 18? What is missing on 6x so that it can give us this 18x to the exponent of 3y? Okay, remember 18 is the same as the product of 2 times 3 squared, which is 2 times 3 times 3. Okay, 2 times 3 times 3, that's 18. So if you consider 6, the number that is missing to give us 18 is a 3. So 6 times 3 is 18, okay? If you consider the variable, this is to the exponent of 3, but this is x. So what are we going to multiply with so that we get x to the exponent of a 3? It means we must have x squared, okay? Remember, x squared times x, you add the exponents, you get x to the exponent of 3. And we've got a y here, and we do not have a y, so we're going to have a y. So that if you multiply this 6x, the one that you are given before this one, if we multiply it by this 3x squared y, we get what? The LCD. That is the major part. That is the major purpose of this. So that the denominators will be the same throughout. It means we must have the same LCD. So you have to ask yourself, what can I do to multiply this term to give me exactly what I have on the what? On the LCD, which is this one. So it means we're going to multiply by what? 3x squared y. So this is what it means. It means we are going to have 3x squared y like this over 3x squared y. Remember, what you do on the numerator, you do it also in the denominator. Multiplied to what? To 7 over 6x like this, okay? Minus, we go to this term, we've got minus 2 over 9xy like this. We want to have this as what? As 18x cubed y. So what is missing on this 9xy? Okay, let's start with the numbers. How can we make this to give us 18? We are supposed to multiply by what? By 2. 9 times 2 is 18. X, like I said, for 6, we're going to multiply by what? By x squared. Already we have the y here, so meaning to say this is what we only need, 2x squared. If you multiply this by 2x squared, it gives you the LCD. But whatever that you are going to multiply with, you have to multiply it on the numerator and also on the denominator like this. Okay, plus you do the same thing here. I'm gonna have 1 over 3 x to the exponent of 3. What am I supposed to do so that this denominator that I'm given, which is 3x to the exponent of 3, will give me the LCD, which is 18x to the exponent of 3y. What is missing? I just have a 3. It must be 18, so I'm going to multiply with what? Okay, 3 has to be multiplied by 6. 6 times 3 gives us what? 18. Or you can divide on your calculator, 18 divided by 3. Then you know that the number that you get is the one that you're going to multiply to get what? 18. So that would be a 6. Already I've got x to the exponent of 3, which is this one. What I do not have there is a y. So I'm going to multiply by what? By 6y. So the moment I multiply this by 6y on top, by 6y below like this, it means we are having 18x to the exponent of what? 18x to the exponent of 3y. That is what it means. So the purpose was making the denominators to be the same. So if we multiply these denominators here, we must have the same denominator throughout. Let's multiply and see. Okay. So you're going to multiply the numerators and see, so 7 times 3, which is what? 21. So it's going to be 21 x squared y like this over, if you multiply 3 times 6, which is 18, x squared times x, which is x cubed, y like that. As you can see, that's your LCD. So do not cancel, because if you cancel everything, you're going to go back here. So don't cancel anything. Leave it like that. Okay, minus, you do the same thing, 2 times 2 here, which is 4x to the exponent of 2 over, if you multiply 9xy and 2x squared, we are going to obtain 18x cubed. So that's x and x squared, which is x cubed y like that. Okay, so as you can see, it's the same. Plus, you do the same, 1 times 6y on top is going to be 6y over 3x cubed times 6y. If you multiply these two, we are going to obtain what? 18x. 3 and 6, that's 18. We're going to have x cubed y in that case. So as we can see here, we can notice that the denominators are the same, and this is the condition that we wanted to have. This is exactly that we wanted to have the same denominators, and we have that, and we have it now. We can see that this is the same throughout. 18x cubed y, 18x cubed y, 18x cubed y. So if this is the same, what does it mean? I said it means you are going to combine everything that you see on top, everything on top together. Okay, so this will be 21x squared y like this minus 4x squared plus 6y like this, everything over that LCD, which is 18x to the exponent of 3y. So this is, like I said, another way of adding your algebraic fractions. This is another way that you can use in adding of your algebraic fractions, and I hope we are together on this method. But if not, then we can use the first one, which is like our traditional way of adding or subtracting our fractions. So this can be used in any type of a fraction, whether we've got these ones which are already in simplest form, like in terms of x, the variables, whatever that you have. Okay, I want us to see number 9. Then I want you guys to try as much questions as you can. On number 9, we are given x minus 3, everything over x plus 3 minus x plus 3 over x minus 3 like this. Of fractions that we have here, like this one, it's already like simplified. Sometimes you have to factorize your expression, but there's no need for you to factorize anything. what you just have to consider is that I have got x plus 3 on my denominator. I have got x minus 3 in my denominator also. So what is the LCD of these two? I'm just going to take them as they are. Remember, the LCD must contain every term that you are given. So x plus 3 in the denominator should be there. Also, x minus 3 in the denominator must be part of this answer of our LCD. It's not a factor that has to be common. A multiple consists of all the terms. So that was supposed to be what? Our LCD. And remember what I'm saying is that what you need with this method is to make sure that you are going to have the LCD throughout on these denominators. So you simply ask yourself, on this x plus 3, this one, what am I supposed to multiply with so that I get x plus 3, x minus 3? So this one is direct. As you can see, guys, we've got x plus 3. So we need what? X minus 3. So that it gives us x plus 3, x minus 3, which is our LCD. So here we are going to multiply. So we are given x minus 3. Okay, let me just multiply on top, guys, as it is, so that we do not waste much time here. Let me try to reduce a little bit. All right. So here, like I said, we are going to need what? X minus 3. So you're going to multiply. But remember what I said, whatever that you're going to need so that this can be changed to the LCD, you must do it both the numerator and the denominator. So like we need x minus 3. So you're going to multiply by x minus 3 over x minus 3 like this. Okay. On this other hand, on the minus side, we have x minus 3. So what are we going to need this side so that we remain with our LCD, which is x plus 3, x minus 3? What are we going to need that side? We are going to need what? X plus 3. So we're going to multiply by x plus 3 over x plus 3. Whatever that you do on the numerator should be done on the denominator also. So that this one gives us a 1, this one is a 1. So it's like we haven't changed our question. We're just rewriting in another way, but still we're having the same thing that we had before. So that's we can solve. Okay, I mean we can simplify. So in this case, taking our fractions as they are, the numerator to the numerator, we are going to have x minus 3, just open a bracket. Also that x minus 3, open a bracket for it. So everything is going to be over the denominators, which is x minus 3, x plus 3, or you can write it as x plus 3, x minus 3. It's up to you, or you can just write as it is x minus 3 into x plus 3. Okay, minus this side, the numerator, we are going to remain with x plus 3 into x plus 3 like that. Everything over what? Our LCD in this case, which is x minus 3, x plus 3, which is the same as what we just have this side, okay? So as long we've got this, remember what I said, as long these are the same, as long your denominators here are the same, what does it mean? It means I can combine the numerators together. So this whole part, I was not even supposed to rewrite this stage. I was just supposed to write with a combined part because I already know that my denominators now, they are the same. So I'm just going to combine everything. I was just going to write this and minus this. Everything over your what? Over your LCD, which is the common denominator that we see here. So this is going to be x minus 3 into x minus 3. Okay, anyways, let us just see minus it here. You're going to have x plus 3 into x plus 3. Okay, so this is the stage where we are supposed to be now. But you can't see, we can't leave our answer like this because this answer is not in simplest form. We have to expand our brackets in case there might be like terms that need to be simplified. We can be able to simplify them. Okay, on the expansion of the bracket of x minus 3 and x minus 3, you can use the longer way of your expansion of brackets by the FOIL method or the distributive method. whereby we're going to multiply by x each and everything here. We're going to multiply by x times x, which is x squared, x times minus 3, which is minus 3x. We are done with x. You move on to negative 3. This one, it multiplies x, which is going to be negative 3x, negative 3 times a negative 3, which will give us a positive 9. So if we collect our like terms, minus 3x gives us what? Minus 6x plus 9. So this expression we could have actually determined this. Remember, we understand that if we are given x minus y like this squared, this is equal to x squared minus 2xy plus y squared. I explained about this formula, because if you write x minus 3 into x minus 3, it simply means I've got x minus 3 squared. So we can use this to expand our x minus 3 squared, okay, which is one and the same answer that you are going to obtain like this one that we used by using our FOIL method, or back to the distributive method, okay? So this will be x squared minus 6x plus 9, okay? So on the other hand, again, you're supposed to do the same thing to expand your brackets, but this side, take note that there is a negative that is there. There's a sign that is in between to say, after expanding this bracket, I'm going to subtract, but whatever that I subtract must be in a bracket so that it can also be affected by this negative that we see that is outside. The negative has to subtract, but what is it that you are subtracting? You are subtracting everything. So everything must be affected by that negative. But the expansion of the x plus 3 is still the same. X plus 3 into x plus 3, we said we can work with the FOIL method or the distributive method. If you multiply x and x, that will be x squared. X goes to the last part there, which is x and 3, which is what? Which is 3x. Okay. Then we move on to this one, 3 and x, which is 3x. Then last, which is what? Which is a 9. 3 times 3, which is a 9. So you're going to have x squared, 3x plus 3x, which is 6x plus what? Plus 9. All right. So if you consider this foil, okay, the FOIL method, we're going to work with first, outer, inner, and the last. The first, okay, together, the outer, okay, then the inner, then the last. Okay, that is the condition. So like I said, the first, okay, then the outer, these ones on the outer part, the inner, these ones inside, then the last, these ones that are on the last part, 3 and 3. So that's your FOIL method. Is that so? So here, this is what you're going to have, and just substitute back. So that's going to be x squared plus 6x plus 9 like this. All right, but do not forget that everything is affected by the what? By the LCD. Everything is still affected by our LCD in this case, which is x minus 3 into x plus 3. So that is the case that you're supposed to consider now, which is very, very important in your simplification. So as you can see, we shall have all these expansions, they shall be there. But after that, are you able to take it back to the normal simplification? So this is where we are now. So what can we do this time is just to expand our brackets. As you can see, in order for us to have like terms, we're going to consider expanding this bracket by a negative, because this is same as there's a negative 1. So remember our distributive, we're going to distribute by negative 1 here. So it's negative 1 times x squared, which is negative 1x squared, which is same as negative x squared. Negative 1 and f6, which is going to be a negative 6x here. Negative 1 and a 9, which is going to be a negative 9. So this will be a negative 9. Everything is going to be affected by the what? By our LCD, which is everything is over x minus 3 into x plus 3. All right. Then now you can consider collecting your like terms, okay? This is same as 1x squared. This one minus 1x squared. So it's a 0. 1 minus 1, that's a 0, okay? Then the part of x, this is minus 6x minus 6x, this one. So it's minus 6x minus 6x, which is going to give us what? Which is going to give us a minus 12 in that case, okay? So this will give us a minus 12 minus 6 minus 6, guys. Even from our calculator, we can simplify. That will be minus 12x, okay? On the numbers 9 minus 9. So this will cancel 9 minus 9. That is going to give us what? A 0. So it means there's nothing that we are left with there. There's nothing that we are left with. It's just going to be minus 12x on top. But remember your denominators, which is your LCD in this case. We're going to have it as it is on our final answer. So this will be over x minus 3 into x plus 3. Okay, so this is how we could have simplified this question. This is how we could have worked out this question using this method. As you can see, there are so many methods, so many considerations that you need to work with. And we shall see that in our next classes, as we shall be working with different types of questions. But what I want you now to do is to work with many questions as you can. Try to understand this concept, try to use this method if possible, or you use the first one, which is fine. We shall just work as much questions as we can. So I want you to try as much of the questions that we are given on this part. We are given to simplify all these questions here, about 13 questions. So I want you to try as much questions as you can, simplify these questions. Wherever you're given a whole number, it is the same as over 1, okay? Whenever you've got a whole number, it is the same as over 1. So yes, 1 plus a is same as everything over 1 like this, okay? So at least you've got a hint or where to start from, okay? This one also is same as over 1 as long as there's a whole number there. So I want you to try as much questions as you can, but if there's a question that we still have a challenge on, let me know about that question so that we can see it in our next class. But for now, that's it, guys.